Okay. Another thing that people did very badly on, although many people did it right, up to a point, and then they did something really bad. I'm not sure anybody even got it. I'm pretty sure somebody did. Okay? Maybe a couple of you. But I got so used to seeing two terrible errors that it kind of obliterated anything right that I'd seen. But I'm pretty sure I saw at least one or two of them right. Okay? Okay, what I'm talking about is this thing where I said f of x plus h minus f of x over h, which is just the slope of a fundamental triangle in this graph. And we'll make that connection, and it's an average rate of change. Okay? But we'll make that connection. I want you to get the notation down before we talk about what it means. This is actually a little bit of calculus, but in the context of a pre-calculus course. Something you will see if you take a calculus course, and many of you should be taking a calculus course, okay? Unless it doesn't apply to what you want to do, okay? Okay, well, anyhow, first thing I saw, let's just look at what f of x plus h is. I kept seeing x squared minus 7x plus 5 plus h. What's wrong with that? I mean, that's terribly wrong. Almost criminally wrong, but I decided not to go to the prosecutor this time. Okay? I mean, I remember one time I wanted to do that. Okay? I didn't do it, and I didn't hand it in. I thought, wait a minute, that can't be right. Oh, duh. Okay? Now, I don't expect you all to necessarily have the oh, duh moment that I did, because I was probably better prepared at that time. And I was in a big old fat calculus course, okay? So I'm not holding you to that standard. But from now on, I am. Okay? That's not what it equals. Well, let's just do this. Plus h. This is not cancellation. This is ain't no way. So let's make sure we understand that we don't do that, right? Look. What does f of x plus h mean? Always. What does f of anything mean? What do you do with what's in here? You replace the x in the definition of the function with this, because it has been replaced with this. Remember talking about this several times, and y'all kind of did it right for a little while, okay? Which is good. Means those neurons are kind of semi-active, so just make them active, okay? You can do that, okay? Now, you know, I've written it out like this, and I said, now this replaces this. Not sure anybody even heard me say that. They just said, oh, you do this, right? Because that's the way you do when you first do something, okay? It's not that, but you want to move past that point of when it looks like this, you do this. No, you do it for a reason, okay? F of x equals this. So what does f of aardvark equal? Well, it'd be aardvark squared minus 7 aardvarks plus 5. Well, whatever, I don't know what the units of these things are, but okay? No, the units of aardvark are. So f of x plus h is x plus h squared minus 7 times x plus h plus 5, right? Okay? So that's one thing. You have to understand function notation, and if you're not seeing it this way, it's clear to me that y'all still need to understand function notation a little better, right? I'm confident you will, because I've seen everybody do it right, okay? If you're not doing it right now, it means you've lost track of something you were doing right a little while ago, okay? So lock it in now. Okay, so the other thing is, Is that right? What do we mean by x plus h squared? We have a distributive law of multiplication over addition. Okay? Is there multiplication involved here in this expression as it's written? You're not multiplying 2 by x plus h. You're raising x plus h to the second power, right? Okay? So I can say that the distributive law is really the distributive law of multiplication over addition. It's not that anything that gets done to this thing can get distributed. It's that if you have a multiplication multiplied by a sum of things, you can distribute the multiplication over the additions. And subtractions, but subtraction is nothing but addition of a negative. Okay, so it works. Okay? Now, I've been writing distributive law, saying you use the distributive law, use the distributive law, because I don't want to write out over multiplication over addition 100 times during the course, right? But that's implicit when I talk about the distributive law, so make sure you understand that. Okay? So what's wrong with this? Well, it looks like misapplication of the distributive law, right? So this looks like the distributive law, but ain't. So you want to lock that idea in, okay? So I'm going to cross this one out. It isn't right. So, if you use the distributive law, and that's what goes in the dots there that you need to write out, you get this. So whenever you have a power of a binomial or a trinomial or anything, I want to see those terms written out. And then I want to see the distributive law applied, right? And this is for your own good, so you don't shortcut it and do this. It's really tempting to do this. Okay, even though I knew better, for a long time I was tempted in writing things down under time pressure to write this, and I had to go, oh, no, you can't do that, okay? So you got to have practice to get used to your tendency to do that, but almost everybody that did this part right screwed it up here. At most, 1 or 2 people got through that problem without screwing it up, okay? And your algebra really has to be up to understanding what you can do with this expression and how you express it. And not just for a quadratic, but yeah. For the quadratic, we work through the details of this thing, okay?